So we know that we need to reduce our metal oxides to metals, and there are several ways that we could do this. The most common way is to reduce it with carbon, which is really cheap and really easy, especially because the carbon actually becomes a fuel to heat up whatever it is that you're performing the reduction in, because it generally requires quite a high temperature. However, it's not always possible, and the carbon tends to remain in some of the product as an impurity, which is not always what we want. Other methods include electrolysis or reduction with a more reactive metal. Now both of these have the downside of being really expensive. The electrolysis because you've got to pay for a whole lot of electricity, and the latter because you actually have to pay for the other metal that you're reducing it with, and that's just being wasted because it's turning into the metal oxide. And maybe you don't have the choice. If you're familiar with the reactivity series, you may know that you will not be able to reduce metals like aluminium and anything above that in the series with carbon because it just won't happen. Well, it will happen, but the temperatures that you need to get that to happen are way beyond what's feasible. So just forget it. And one obscure case that I will go through right now is the reduction of tungsten oxide to tungsten. Because you might think, oh great, you could do it with carbon, that's fine. But no, not exactly. Because if you try to reduce tungsten oxide with carbon, you end up with tungsten carbide, which is not what we want. Instead, a stream of hydrogen is used. So you take your tungsten oxide and you heat it up between 800 and 1100 Kelvin, and you blast it with hydrogen, and the hydrogen reduces it, and you get water, and the stream of hydrogen carries that water away, and it just keeps happening until all you're left with is tungsten metal and some water left over elsewhere. This is not a very common occurrence, and if you can do it with carbon, you really recommend that you should, because this is fucking dangerous. Hindenburg, anyone? Hydrogen burns. So yeah, you take great care to make sure these machines are really super airtight, because tell you what, when air gets in, that's fucking doomsday.